Understood. So today, see, how does it exactly work with the Hess's law? Very simple. So this is how the questions would be.
Yeah.
Okay. So for example, when the question is talking about the Hess's law questions, right? So it would say something like this. It says calculate, calculate the heats of formation, heat of reaction for the following reaction. So you have to calculate the heat of reaction. Heat of reaction means
Yeah.
that during a particular reaction, how much amount of heat has been lost or gained in that particular reaction. So if the heat of reaction comes out to be negative, you say that the reaction is exothermic. And if the heat of reaction comes out to be positive, you say that the reaction is endothermic. Yes or no? So when we are
Yes.
talking about the heat of the reaction, just understand that when we are given this particular reaction, so when we say CH2 double bond CH2 plus H2, it gives me CH3 single bond CH3. Okay, that's the reaction. And I
Right.
have to calculate the heat of reaction of this particular reaction, and the given data for me would be here. So the given data shall be this, right? What is the data? The data says carbon plus H2 gives me C2H4, because if you see, this is C2H4, right? Then it says, right? And then it also says that C plus H2 gives you C3H6. Something like this kind of data they would give you. All right?
Yeah.
Something like this. And now it would require me to do what? Understand? It would require me to do what? It would say that for this particular reaction number one, the amount of heat is going to be delta H formation. So basically, the question will not tell you whether it is delta H formation or not, but you have to understand from the data itself. This is a basic method of how we solve the equation using Hess's law, whereby the question will give me certain reactions, reaction one, reaction two, but it is not going to tell me how or what information this reaction is depicting. So it would simply say delta H naught would be, let's suppose, 500 minus 500 kilojoules per mole, and delta H naught would give me a minus 800 kilojoule per mole. That's it. Or minus 1800 kilojoules per mole. So this is the data given to me. And using equation 1 and equation 2, I am supposed to calculate the energy for the reaction number 3. This is my main reaction. So you understand that how do I actually see through this question? Just have a look at the first question. Don't you see that carbon and hydrogen are pure elements?
Yes. Right.
And carbon and hydrogen being pure elements, then when they're joined, they are producing the final product. They are producing the final product. I hope you're understanding.
Yeah.
So when they are producing the final product, what does that mean? That means that, ma'am, this is the heat of formation because it is C2H4. C2, two carbons are there, so it is eth, and it is double bond, so it is ethene, and this is ethane. This is ethane. This is going to be C2H6. The balanced equation should be C2H6. So this is ethane. So I hope you're understanding that when we talk about ethene and ethane being reacting to each other,
Yeah.
right? So what exactly is happening? You tell me. C2C plus H2 gives you C2H4. How do I modify these equations? See, I need C2H6 on the right hand side. On the right hand side. Right. And I need C2H4 on the left hand side. You understand?
Right.
So how do I modify? So don't you think that I should, reverse my reaction number one?
Yeah.
And reaction number one's information tells me that delta H is minus 500 kilojoules per mole, which means delta H would become what? Delta H would basically become minus 500 kilojoules per mole. That basically becomes what? That basically means it is an exothermic reaction. But when I reverse it, I hope you're understanding this has become an endothermic reaction. So I'm going to modify my reaction number one and I'm going to write it down this way. So I'm going to say 2C2H4 will give me 2C plus 2H2. And you need C2H6 on the right hand side. So my second equation gives me C2H6 on the right hand side. This is my second equation. And this second equation gives C2H6 on the right hand side. I hope you're understanding.
Yes.
What does that mean? That basically means that 2C plus 3H2 shall give me C2H6. So for delta H1, I'm going to write it down as plus 500, though it was minus 500 in the initial stage. But since I've reversed the reaction, so forward reaction is exothermic, minus sign indicates exothermic. So backward sign indicates endothermic. And delta H represents what? Delta H2 shall represent plus minus 1800 itself because I have done nothing to the second reaction. I hope you're understanding.
Right.
And when I add it up, what exactly does it make? It makes minus 1300 because when I add it up, I get two carbons, cancel two carbons, and 2H2 cancels 2H2. So I'm left with just one H2. So when I add it up, it becomes C2H4 plus H2. It gives me C2H6. Don't you think that it has generated my entire reaction?
Yes. That.
And I have to add the two equations because what is the basic theme of the Hess's law? That if you want to produce the main reaction by using some other reactions, I hope you're understanding, by producing some other reactions. So what would happen? Just tell me what would happen. So if I'm adding the two reactions, I have to add their heats as well. And you understand in this very basic reaction, I have not done anything with the equations. Neither I have multiplied the equations with any number 2 or 3. I have simply added the equations. So I hope you're understanding C2H4 when added with H2 will give you C2H6.
Yeah.
You understand my point?
Yeah.
So that is the concept. That is the concept. You understand?
Yes.
Right? So that's how things basically work. So you are given a main reaction, and from that main reaction, certain subsidiary or certain helping reactions with their heats would be given. And using those heats, I will have to add and subtract and reverse and modify so as to get the main answer as my product. Do you understand?
Yes.
Okay, so this is how we basically solve all the questions in Hess's law. So please
Okay.
copy this down and then we'll do some more questions on that.
Yeah. Just a second.
It says how much heat is being produced, how much heat is being produced by burning 4 moles of acetylene under standard state conditions. Under standard state conditions. All right. Under standard state conditions. Right.
Right.
And what is given to me? The delta H combustion standard is given to me kilojoules per mole. So this is the question. So what first of all you understand what is acetylene. So sometimes you have to just understand the question that the data that they've given to you is that for the combustion. Delta H naught combustion is given to you. What is delta H naught combustion? Tell me. The amount of heat reduced on the combustion of 1 mole of a substance. You understand?
Right.
So the
Yes.
amount of heat produced on the combustion of 1 mole of a substance. What would that mean? You tell me. Right? So this data is given to me. So basically, amount of heat produced during the combustion is given to me per mole. That if you burn acetylene is first of all ethine. So if you burn 1 mole of a substance in the presence of oxygen, it is going to give you
Yes.
CO2 and H2O, isn't it?
Yeah.
And if it is going to give you CO2 and H2O, what would that mean? That CH triple bond CH is there. You understand? And when you burn this reaction, when you burn acetylene, or you also call it as ethine, so 1 mole of this that you're burning, if you balance out this equation, so you get H2O and CO2. So I'm going to put 3 by 2 O2, and I'm going to put 2 carbons here as well. So 4 and 1, 5. So you will have 5 over 2. And you multiply with 2. So this cancels out, right? And this also multiplies with 2. So this becomes 4, and this becomes 2H2. So 6, 8, and 10, and 10. Yeah. So this is the equation. So in this equation, 2 moles of oxygen is getting burned, 2 moles of acetylene is getting burned, and for this particular reaction, the heat is not given. The heat of combustion is given to you. So basically, it is a very direct question. What you could do that, ma'am, for 1 mole combustion of heat of combustion, even if they do not give me, mole, just writing down this is sufficient. Delta H combustion is this. So by the definition, you should know that you're combusting 1 mole of a substance. So 1 mole of substance on combustion, 1 mole of substance on combustion shall give you what? 1301 kilojoules of energy. And we are combusting here 4 moles. So 4 moles of combustion, 4 moles of substance on combustion shall give me what? 1301 into 4. So 0, 4, and 12 and 5. 5204 kilojoules per mole. Are you understanding my point?
Yes.
Any doubts in that? Right? So this is a question. Like for example, it gives you this. See, done? Now write down the next question. It says this. It says 2-methyl propanol. 2-methyl propane 1 can also be converted to produce diesel and jet fuel. So basically they are giving you C4H10, C4H10O, right? And that is giving me C4H8 plus H2O. So 2-methyl propene. That is 2-methyl propene. And that is 2-methyl propanol. 2-methyl propanol. Right? Now it says using the data given below. What is the data given to me? 4C plus 5H2 plus half O2 gives you C4H10O. 4C plus 4H2 gives you C4H8. And H2 plus half O2 shall give you H2O. Energies for all of them is given to you as minus 335 kilojoules per mole. Energy for this is given to you as minus 17 kilojoules per mole. And delta H for this is minus 242 kilojoules per mole.
Yeah.
So this is the question given to you. And you have to solve this. Yes or no? Now,
Yes.
what do you think you would be able to solve? Understand. When we are talking 2-methyl propane 1-ol can also be converted to produce diesel and jet fuel, what exactly do you think is happening here? See, I need 2-methyl propene on the right hand side in my main reaction because that's my main reaction. And I need H2O as well on the right hand side. So using these equation number 1, equation number 2, and equation number 3, do you realize that C4H8 is on the right hand side and H2O is also on the right hand side? Just tell me.
Right. They are.
And what about C4H10O? What about C4H10O? Tell me. C4H10O I need in the left hand side in the main reaction.
Right.
So just this understanding of this will tell you which reaction has to be reversed and which reaction is not to be reversed. You understand?
Yeah.
So if you have C4H10O on the left hand side, so that clearly tells me that to find my final answer, I need to just reverse my first reaction. So my first reaction, I'm going to just write it down in the reverse manner. And understand in my balanced equation here, I need 1 mole of this, 1 mole of this, 1 mole of this. So basically 1 mole, 1 mole, 1 mole is being produced.
Yeah.
So I do not have to. So for example, just understand. So for example, if in the main question this would have been, let's suppose two C4H8. So that indicates that this equation has to be multiplied with 2 because only then I can make 2 C4H8. Are you understanding? And by
Yes.
multiplying this equation, if I get C4H8, then I am in a situation to do what? Then I am in a situation to do what? Tell me. If I get C4H8 right here, then doubling it and then adding or subtracting. But right now there is no need. Reason being in my main equation, it is all the coefficients are just 1. You understand?
Yeah.
Okay.
Right.
So that is the concept. Now what do you do? Now what do you do? You basically add them up. So what do you get? So it becomes C4H10O. I'm reversing it, and that is going to give me 4C plus 5H2 plus half O2. Yes or no?
Yeah.
And now if you add these equations, just try and add them all. So you see, left reactants will add to reactants, and the products shall add to products. In the product side, C4H8 plus H2O, 4 carbon cancels 4 carbon, 4H2O and 5H2. 5H2, 4H2 and 1H2, 5H2, 5H2 cancels 5H2, and half
Yes.
O2 cancels half O2. Yes or no?
Yes.
So if I'm reversing my first reaction, so its heat shall become positive, so that shall become 335 kilojoules per mole. And now my final reaction shall be C4H10O shall give me H2O, C4H8 plus H2O. That's it. And Hess's law is all about that if you are adding all the reactions to give me the main reaction, that means what? That means you need to add the energies as well. And what energy would you get? Tell me. You will get minus 17, minus 242. Yes or no? So it shall become minus 17, minus 242, and plus 335. Basically, this. So if
Right.
you know, so 7 plus 2 shall be 9 and 5, so 259. So minus 259 is there. Yes or no? And plus 335. So basically
Yeah.
15 minus 9 shall be 4, and so 12 minus 5 shall be 7, and 3 minus 2 shall be 1. So it shall be plus 174. That means what? That means what? That this is going to be an endothermic reaction finally. So this reaction will involve. So that is delta H reaction. I hope you're understanding. Why? Because you
Yes.
have to modify the equation in such a way that you get the final answer as the main equation. And along with that, when you know the individual energies, you also know how to add and subtract the energies. I hope you're understanding what I'm trying to explain.
Yeah.
Right? So that is the question. Right? Next question we see. Question number 3. Just do this. So question number 3 tells me Yes, this says B2H6 plus 3O2 gives me B2O3. Okay, this is my main equation whose energy you have to calculate. So for this, delta H reaction has to be calculated. That you know how much heat is being absorbed or released during this particular reaction. That is to be calculated. What is the given data? The given data for me is this. It says 2B plus 3H2. 2B plus 3H2 gives me B2H6, and H2 plus half O2 gives me H2O, and 2B plus 1.5 O2 shall give me B2O3. And delta H reaction for this is plus 36 kilojoule per mole. Now, first, by looking at the reaction, you have to tell me what enthalpies are given to you basically. What enthalpies are given to you? You understand?
Yeah.
So, this is the reaction, right? Now, understand what is my equation? B2O3 I need on the right hand side, and that is in the standard reactions also, in the given data also. It is on the right hand side. So, no need to reverse it. I need H2O on the right hand side. So, it is on the right hand side. The only thing is that, I need 3H2O because these are the equations. Using these equations, I have to actually frame this main equation. Energy, the answer to the question shall follow automatically. So these are
Okay.
basically observation based questions. I hope you're understanding. So if I have
Yeah.
these energies, so using these reactions, using these reactions, what do you think I have to do? Tell me. Using these reactions, I have to do what? I have to make the main equation. This is my main equation. So just have a look. What do I need? Because when I add the equations, the products appear on the product side, the reactants appear on the reactant side. So this is my product, and I want this in my main product also. B2O3 is my product, and I need B2O3 in the right hand side only in the main reaction. You understand?
Yes.
So that is how we are supposed to solve this. So what exactly happens here? Just see. So, but I need to multiply the second equation with 3. Why so? Why do I need to multiply the second equation with 3? Because this is going to 3, 3O2, and 3. Because I need 3H2. You understand? And then I have to multiply the energy as well with 3. So here, my modified energy would become 2 times 3 times 286. 3 times 286. What shall be 3 times 286? You tell me. What shall be 3 times 286? It shall be 600 and 240 and 18. So it shall be 8 and 5 and 8. So it shall be 858. It shall become 858. Though the given answer was how much? The given answer was 286. But I have to multiply with this with this. So it's going to become 600 and 858 kilojoules is the energy after multiplying with 3. So this modification I have done. B2O3's coefficient is 1, so I have also made it 1. And then I have B2H6. I hope you're understanding.
Yes.
So simply now add the equations. Now, I need to reverse any equation? Yes. I need to reverse the B2H6 equation because B2H6 is on the right hand side in the helping equations. But in my main equation, I need B2H6 on the reactant side. So I'm going to just reverse it. So B2H6 comes here and it gives me 2B plus 3H2. 2B plus 3H2. And because I've reversed the equation, my delta H also becomes minus 36 kilojoules per mole. And now this is my 1 dash equation. Why 1 dash? Because that's a reversed, the modified equation. And that is also my 2 dash equation. And now I'm going to add the 3 equations. Which ones? The second equation, the third, and the 1 dash. Because 1 dash has been not reversed but modified by multiplying by 3. Are you understanding?
Right. Yeah.
And now when I add them up, just have a look. When you add the reactant, just see it becomes 3H2 plus 3.5 O2 plus 2B plus what? Here it is going to become what? One and a half is basically 2 times 1 plus 1, 3 over 2 O2 again, and plus B2H6. And on the right hand side, I get 3H2O plus B2O3 plus 2B plus 3H2. So 3H2 cancels 3H2. Just have a look. And 2B cancels 2B. It's like plus go comes here and becomes minus. It is that sort of mathematics with the
Yeah.
chemicals as well. Now, what is 3
Yeah.
by 2? 3 by 2 is nothing but 1.5. 1.5 plus 1.5, Shruti? 3. Yes or no? 1.5 plus 1.5 is 3. So can I just combine
Yes.
these two and become, so this is going to become B2H6. And 3 by 2 plus 3 by 2 shall become 6 by 2. That becomes 3. So that becomes 3O2. And here it becomes what? B2O3 plus 3H2. So you see, I have created the main equation using the helping equations. But a little bit of understanding and observation is required to, understand who to reverse, who to modify, who to multiply. That sort of modification and that sort of understanding you would be required. You understand?
Yes.
And now with this concept, so you have the energies right here. So minus 858, minus 1274, and minus 36. So all these equations, these energies to be added to get the final answer, because that's what exactly we were supposed to do, to add or subtract the energies. But these equation modification will tell you whatever you have done with the equations, the same thing you will be doing with the energies. But
Okay.
you just realize that, when I reversed my first equation, the energy was plus 36, and I have written here minus 36. Because when you reverse, exothermic becomes endothermic and vice versa. I hope you're understanding.
Mm. Yes.
That is why. So it was endothermic given to me, and now it has become exothermic. Understood or not?
Right. Yeah.
So B2H6 plus 3O2 is going to give you B2O3 plus 3H2, and here it is going to become minus 36 because all of them are minus. So straight away add them up, and in the later ends, apply the negative sign. So it becomes 12 and 18, and 1 and 8, 9, 10, 11, 12, 13, 14, 15, 16, and 10, 11, and 2168. So my final answer shall be minus 2168 kilojoules is the heat of the reaction, delta H reaction. That shall be delta H reaction. Understood or not?
Right. Yes. Makes sense.
That is the answer.
Okay.
Right? Now do one more question. So basically, this is how Hess's law works. Given data has to be converted into the final answer. Now just have a look here. If I give you one more question. So now, acha, one more thing, Shruti. Just tell me the names of the given equations. Just tell me. In the first equation, do you think that B2H6 is being produced from its native elements B and H2?
Yes.
So B2H6 is being produced from boron and hydrogen. That means
Yes.
what? That means what? You tell me. That boron and hydrogen they combine to form B2H6. So, and 1 mole of B2H6 is being formed in the original equation. That means it is heat of formation. Because just
Yeah.
recall the definition of heat of formation, the amount of heat released or absorbed during the formation of 1 mole of a substance. During the formation of 1 mole of a substance. I hope you're understanding,
Yes.
right? So if this is the equation that is given to me, I hope you're understanding how exactly. So they will never tell you that, what heats they're giving you. They will simply tell you this is the reaction, this is the heat. You have to, while solving the question, understand what heats they're actually trying to give you. So this is actually a heat of formation,
Okay. Right.
isn't it? What about this? It is going to be 3H2 plus 3 by 2 O2. So when it gives you 3H2 plus 3 by 2 O2, what does that mean exactly? You tell me. that this was actually H2O, 1 mole was being produced. Forget about 3 because that was not the equation. From its relative elements, like H2 and O2 were combining to give you H2O. I hope you're understanding.
Yeah.
And here also 1 mole of B2O3 was being produced from its relative elements, from the native elements, boron and oxygen. So all these three data was actually the heat energy of heats of formation was given to me. Yes
Okay.
or no? So using the heats of formation, we were supposed to calculate what? We were supposed to calculate the heat of a particular reaction that is given in the main question. Understood? So
Yes.
not necessarily every time the energy would be heat of formation, but sometimes in these questions that you're doing for the start, they have heats of formation. Now, identify in this question now. How much time is left, Shruti?